All right, let's see. This is the thing. Everyone can hear me, hopefully. All right. And there we go. All right. Cool. So thank you all for attending. I am very honored to be here, my first time in Switzerland. I apologize for interrupting, I think is what the start of the soccer game. So if anyone wants to shout out scores as I'm going along, I would not be offended. So this talk is titled No Silver Bullets for Digital Vampires, DLP, or Data Loss Prevention Security for Mortals. So of course we have our Blade who is about to kill our least favorite vampire. So before I get into the meat of the talk, just the requisite background information slide. My name is Kelly Lum. Some people know me as Aloria on Twitter, unfortunately, or not. I am a security engineer at Tumblr. I am also an adjunct professor at NYU Engineering, where I teach application security. Before I started at Tumblr, I've kind of been all over the place, been in security, officially for about 12 years. So I have worked in military, in government, in nonprofit, and also in finance. So I've worked in a lot of places where DLP has been either in use or something that has been considered for use, which is one of the reasons why I thought it would be interesting to look into some of the things that are out there. So in terms of our agenda, I just do all these. I don't know why we did it like that. Oh, nope, never mind. So first we'll just do an overview of what DLP is, why people use it, how it is used, and we'll kind of go into the breakdown of the different targets that we picked. When I say we, this research was done in conjunction with a friend of mine, Zach Lanier. Some of you may know him as Quine. So he is also somebody who wrote the Android Hacker's Handbook, so he's a real smart dude. Look him up. But so we're going to go over, what DLP is, what the targets are, and what their components were, what the components are of those targets. And then we'll go into sort of the techniques, the kind of methodology that we went through in order to test and kind of put these targets through the paces in terms of, mostly when we're doing this, we're evaluating the security of these products. Whenever you take a piece of software, a piece of hardware, whatever, put it into your infrastructure, you're potentially adding more attack surface. You're potentially putting something that may be insecure into your infrastructure. So that's a question that we should want to answer, right? How secure are these security products? Then we'll do, some conclusions, some final thoughts, and then I'll open it up for questions. So why DLP? Why not some other product? And kind of the reason is this bullet shouldn't say used to be a hot button topic. It kind of still is in terms of not maybe DLP, but the fear and the frequency of data breaches that have been happening. You see them in the news all the time. There's Home Depot, there's Target, there's people's password lists getting stolen or leaked somehow. So people were like, how are we going to do this? How are we going to get rid of this data loss problem? Oh, here we go. Here's a silver bullet. It's DLP. We throw it into our network or install it on our machines, then we'll be fine. We don't have to worry about anything anymore. Okay? The way that DLP is normally sold, and as I'm going through this, you'll just see some news articles from a few years back about things that people are freaking out about getting their information taken from them. The way that DLP is usually described, or what its utility usually is keeping honest people from doing dumb things. So you have the person who goes through the HR paperwork. You want to discourage that person from putting that sensitive information, tax forms, social security numbers, addresses or whatnot. You want to discourage that person from putting it on a thumb drive and taking it home with them, or sending it to their personal email address so they can work on it while they're on vacation or whatnot. And that is really kind of the way that we want to think about DLP. Some people do worry about, let's say, like the Bradley Manning sort of thing, which we'll get to that later, but in terms of the utility of DLP, we really kind of want to keep the honest people honest. The advanced insider threat is a lot more difficult, and again, we'll talk about that later. And again, the reason why people are freaking out and looking at DLP to maybe let them sleep a little better at night is all of these data breaches that are happening. You don't want your company to be the next company that's on the front of, Gizmodo or, God forbid, the Wall Street Journal or the New York Times because you had a massive data breach. You have to inform, thousands to millions of customers or whomever that, hey, we screwed up. Your stuff is in the hands of bad people. So that's why people choose DLP, and the reason that we decided to look at it was, again, we're curious about the attack surface. You buy something from a company, the products that we're looking at will range anywhere from, 5-digit licenses in terms of cost to free, but you're putting your trust, you're giving either money or time or both to getting one of these products into your organization. And if the product is vulnerable, then you've made yourself a little bit more vulnerable just because of the added attack surface. We're also interested in reliability. As we'll talk about some of these, with DLP, the way it works is it has to look at the data that people are dealing with. It has to look at file transfers. It has to look at things that are copying and pasting. It has to maybe monitor network communications for things that look shady. If those things aren't reliable, if they're constantly crashing, if they're making things super, super slow, that's not going to be good for anybody who's trying to get serious work done. And in addition to other security products that you probably all have worked with or are familiar with, things like firewalls, like IDS, the position that DLP needs to be in your organization is usually somewhere that is very, very attractive to maybe an attacker who wants to get as much information out of your company or out of your network or out of your system as possible, right? If you have to monitor all the traffic, then that's a perfect place for me to kind of go after to try to pop that box or whatever to say, okay, I'm in here, now I can see all the data that's flowing through that they were worried about people stealing, and now I can steal it. And also, so the joke I always make is I'm from Brooklyn. Most people in Brooklyn are, like the stereotype is we're all hipsters, and so we really like irony, right? And so testing the security of security products is kind of just a fun thing to do. It's kind of funny in a way. Also, sometimes it's sad. We'll get into that. One last thing. So one of the trends we'll see when we look at some of the bigger name products is there is also this kind of trend, and you don't see this just in DLP. You see this in other pieces. You see this in pieces of software, other pieces of security, hardware, whatever, where the big vendor, they see, like, we need to make more money. We need to be more competitive with what other people are offering. Oh, look at that small company. They do something cool. Let's buy them. And then they maybe buy 3 or 4 small companies, bundle them all into one big security suite, and then forget, they lose all of the institutional knowledge of the company that they just bought out, right? They don't know what exactly they're rolling into their product. Maybe they're not evaluating the thing they bought to make sure it's secure. They're like, oh, well, these people said it's okay, so they have a penetration test report, it's fine. So in order to talk about things that people have done in the past before we get into what we've done, so SecureRosis has done, you probably Google it, they've done a bunch of blog posts and white papers on DLP security. Back in 2007, Matasano, which I believe is now part of NCC, they did a talk about defeating DLP. There was also a talk at DEF CON 19 about basically using Opendlp to steal sensitive data. So that was given by Andrew Gavin. And there were a bunch of others. This talk has been done in various iterations at other conferences. So this is basically, we broke our research up into a bunch of different vendors. So this is all of like the complete gamut of all the stuff that we looked at. So I'm not sure, hopefully people can see this all right, but this is just an example of how DLP would sit in terms of the DLP architecture and where it would be situated inside an organization. You may have, depending on the product that you're using, depending on the features of the product that you're using, you may have all of this, you may have some of this. So usually what you'll have in the center is a DLP management server. Does this do the little thingy? Oh, it does, cool. Okay, Dlp Management Server, which talks to a database where you're going to keep all of your policy and reporting information. And we'll talk about how you define that in the next slide. Okay, the Dlp Management Server is responsible for taking those policies, for those signatures, whatever you're looking for, and pushing those out to, let's say you have a network monitor because you want to monitor traffic to see if people are maybe, taking large files, taking files that they shouldn't be transferring, and moving them to places they shouldn't be going. Maybe you want to monitor things on the workstation, such as somebody trying to copy and paste something out of a classified document or a document that has certain types of metadata. You want to catch them trying to paste that into an email. You may want to look at your mail server. Again, maybe somebody's trying to send something outside of the organization, or maybe receive something inside the organization that has something sensitive, and you want to go investigate that. You might want to look at your databases. A lot of times, especially when we're talking about credit cards getting stolen, passwords getting stolen, somebody's going to be pulling out lots and lots of records of your database. If you can catch those records being taken out, then you may either be able to stop it, or you may be able to react a little bit faster than finding out because you saw it on Pastebin. Another thing that Dlp uses, and so this kind of is not, this usually isn't Dlp, sometimes it is. Sometimes people will monitor what's going on the web. So they want to make sure that people aren't copying and pasting, let's say, insider information or sensitive corporate information into like a web forum. But they'll also kind of, as a selling point, use these Dlp policies to say, these are the sites you can't visit. These are the, you're limited to these sites, or these sites are blacklisted. Just as an additional, okay, well, not only do we get to protect your company from having its data stolen, but we can also prevent your employees from looking at porn. So just to go more into the architecture, that go from network to sort of how it works in terms of, you have these policies that are living on your management server or whatever, and wherever the Dlp endpoint is, whether it's a network monitor, a mail server monitor, or a workstation monitor, it's going to be, those policies are going to be talking to a bunch of different things. So this is basically closer to where the user sits, and this is more in the back end. So what are some of the things that Dlp can look at? Well, they can monitor your clipboard to make sure you're not copying credit card information or social security numbers somewhere. Maybe you want to look at your removable devices. Again, the person who takes sensitive documents and puts them on a USB drive, or burns them to a DVD or whatever. You want to monitor to see what people are doing in that respect. Sometimes you actually want to monitor documents, right? So somebody opens up a classified file, maybe you want to log every time somebody does that. You want to see if people are trying to access things that they shouldn't be accessing, see if people are putting information into documents that they shouldn't be putting in. So you might want to indicate which files you want to look at. Maybe you only want to look at Microsoft Office files. Maybe you want to look at database files. Maybe you want to look at XML text. Maybe there's some binaries that you want to look at. These document and file parsers can be implemented in one of two ways. Sometimes there's a crawler, sort of similar to like an antivirus scan, that's going to look through all your files and see if there's a pattern match. Sometimes it's a real-time monitor. So somebody opens the file, manipulates it, it's actively looking at what the user is doing. Okay. We also have protocol analyzers. So you would say, I want to look at FTP, I want to look at connections to weird IM services, whatever it is. So you're going to have interface with your network driver, and you're going to have something that's monitoring the communications that are going onto your over your network. Okay, the inspection engine is where they take all the information from these parsers and basically says, is this okay, is this not okay? And then you have an enforcement engine. Sometimes you'll actually want to actively block something. There's some Dlp solutions I've seen where you try to copy and paste something you shouldn't, and it'll actually pop up and say, you're not supposed to do that, it's been reported to the content police or whatever. And a reporting engine. Sometimes you just want to see what's been going on. Maybe get hourly, weekly, daily, whatever reports to see, like, this is what people have been trying to do. I'll try not to go on to this kind of soft stuff. This is the last one, but this is sort of just an example of a workflow of somebody who's working with DLP. So first you're going to identify what you want to look at. Maybe you have some keywords, maybe you have like fingerprints in terms of certain binary data, maybe you have regular expressions, right? You want to match for social security numbers, for credit cards, for things that look like, I don't know, email addresses. And then you have file attributes. So the files, certain patterns for certain files you might want to look at. Then you're going to define what the rules are. Okay, you're going to say these things are allowed here, these things aren't allowed here, so on and so forth. Once you do that, you're going to create a policy saying, here are my targets. Maybe you have different policies for different people, such as the people in the HR department are allowed to work with personally identifiable information. The people who are the graphic designers, they have different policies on their machine. They should not be looking at credit card or personally identifiable information, right? You may want to select which network channels you want to look at, and then what is the action you want to do? Do you want to block it? Do you want to log it? Do you want to log it silently, or do you want to log it and say, hey, don't do that? You deploy the policy to wherever your agents are, and then you go into your monitoring, where you're looking at logs, you're looking at reports. The other thing that you can do is, when I said more like an antivirus scan, where you go and do data discovery, where you're crawling your systems for certain things that may be of interest to you. And again, just to kind of drive the point home, the ability to do all of this means that DLP has to be very, very powerful. It has to have access to a lot of information. The fact that DLP needs to look at your data to determine whether or not it's good or bad data, or sensitive, non-sensitive data, means that DLP, if somebody can compromise it, they're going to get access to a lot of stuff. Okay, so before I go into, we're going to talk about our targets, and then we're going to get to the good stuff, all the vulnerabilities and whatever we found. All the vendors have been notified of the findings. As far as I know, there aren't any outstanding patches that need to be done. Some vendor names have been changed to protect the innocent, just because we didn't like people saying that they were going to send us nasty letters. Okay. So let's talk about the targets that we looked at. Again, we did this in 2 rounds. The first round, we looked at more kind of big name vendors, and then the second round, we looked at a little bit more boutique startup offerings. Okay, so round 1, and we'll go into the stuff first, but we have Trend Micro, Sophos, WebSense, and just for good measure, we threw in an open source one, which is Opendlp. The endpoint agents, you see that there's Windows for Trend Micro, endpoint is also Windows for Sophos, and endpoint for WebSense is Windows, Linux, and OS X. Opendlp is entirely Linux. The management appliances, you'll see Trend Micro has Linux. The enterprise console for Sophos is Windows, but their UTM appliance is Linux, which is more of the management stuff. The management server and WebSense is Windows, and their data security protector appliance, which is sort of a scanner, is Linux. So just kind of all over the place in terms of the operating systems that we see. We do see that the endpoints tend to be Windows-centric, with the exception of WebSense, which supports the big 3. So I won't go too much into all these, just sort of what the interesting stuff is. So they have the Windows Endpoint Agent, which does the monitoring and the enforcement. The weird thing about the Windows Agent, it actually acted like a rootkit. Basically, you install it, and you're like, where the hell did it go? It's not here. Basically, you install it, and it hides itself. I can kind of understand the rationale behind that, where if you are kind of worried about somebody a little savvy or somebody who actually is deliberately trying to do bad things, hiding the fact that they have something monitoring them may put them into lure them into a false sense of comfort. Maybe you can catch people easier. It was just a little shady looking when a piece of software does that. Can make it very difficult to kind of get rid of that piece of software if you, for whatever reason, don't want it on there anymore. The network agent is a virtual appliance. It basically sits on the network, does what it says, monitors network traffic for the stuff you want to monitor. There's something called a remote crawler, which will basically go out and look for machines that are not part of your corporate network and try to say, well, why is this here? This isn't one of our, this is a machine that is on our network that doesn't have an agent. What is it doing? Why is it there? Maybe a consultant brought in a laptop, just trying to figure out what's on your network or what's there that shouldn't be. And the management server, is Linux-based. Again, it's a virtual appliance. You get a VM, you install it wherever you want. Okay. So the management server is this management console. It's Apache Coyote on Windows and using an MS SQL database. So a lot different than Trend Micro, right? It's a Windows-centric management. The endpoints, again, big three, so a lot more support here. What do? They look at file and network drivers. They also monitor clipboard operations. And then there's this protector appliance that has this weird restricted admin shell. We really didn't look too much about that, but we also have crawlers that can basically go around on systems or on network shares and whatnot to look for sensitive documents. Okay. For Sophos, our management console is Windows. Whole lot of .NET. We'll get into, where does that show now? Okay, whole lot of .NET, which we'll talk about a little bit later, why that was interesting. It's one of those kind of bundled solutions where you get your endpoint security, so you're not just getting DLP, you're getting antivirus, DLP, and whatever for your different operating systems. Oh, okay, that's fine. I hate these slides. Why do you do it like that? I don't. Okay. Opendlp is just the Linux virtual appliance. It is Apache and a whole lot of Perl. I personally don't dislike Perl, but Zach was the one who looked at this, and he got very, very upset at all the Perl. It also has a Windows agent, and it also has something that is a file system crawler and a document crawler. Also, this SSH FSBIS crawler, and also Metasploit modules, which I thought was weird. I guess if you wanted to make Opendlp like a payload or something, it was just that was an interesting feature. So one thing that we also wanted to mention is, as we looked at these products, not Opendlp, of course, but we noticed that there's this thing on a lot of them called KeyView, or KVOOP, which is Keyview OOP binary. This showed up a lot. Don't ask me what OOP stands for, I don't remember. Yeah, you know me. Part of the Keyview filter SDK, it's used for parsing, normalizing documents. Basically, it makes sense that this would be on a lot of things that need to parse documents because it's a library for parsing documents. It's used in a lot of DLP products. It's also used in messaging servers and a lot of big data platforms. So this is not just something that's unique to DLP. This library is in a lot of places. So, why am I bringing this up? Well, if you're somebody who likes to find a bug that affects a lot of things, then this is maybe something you might be interested in looking at. Okay, so for example, in WebSense, we have this thing called EP Classifier, and it basically spawns all these KVOOP processes, and what it's doing is creating a policy engine filter and then looking at documents that are either living on the file system or are being looked at. All right. We're almost done with the overview stuff, okay? I promise. So who did we look at? Again, we changed these names just because, one, it just kind of felt like a good idea, and two, they are smaller vendors. We probably should have done it for the big names, but I think they can kind of handle the criticism because they have a lot of money. I don't know. So we named up Alpha, Bravo, Charlie, and Dingus. Dingus because Dingus may or may not exist in the real world. Again, the virtual appliances here, they are all Linux. The endpoint agents are all of them support Windows. The Charlie and Bravo support OS X, and Charlie supports Linux. And let's see, do we have anything else? The Bravo Dlp Management Server is in Windows, but that's the only one that has a management server in Windows. All right. Okay, so this is a slide where I'm going to get angry. Alpha DLP was, how am I going to, okay. So I've noticed in security, or talking to security people, looking on Twitter, reading message boards, there are certain vendors and certain technologies that we kind of like, and there's ones that we really, really don't like. So Alpha DLP was just like this weird Frankenstein's monster of everything. Just makes me upset. First of all, it was previously an open source product. The people grabbed the code base and basically closed off the code. That's not cool. The admin panel is entirely in Flash because apparently it's 1998. And the Windows agent, like, I understand, like, how like when you're a little kid and your mom or your dad takes you out to get ice cream and they're like, what you want on your ice cream? And you're like, I want gummy bears. No, I want hot fudge. No, I want marshmallows. No, I want sprinkles. No, I want cherries. No, I want all of them. And you're like, you get it, and you're like, I'm going to die because this is too much. So basically, I kind of feel like that's their attitude in terms of how they built this out, because it's made of .NET, Java, and Erlang. And I thought that .NET and Java were supposed to be like enemies. So, okay, yeah. And just, this is bad enough, but just to make you, if you're not already kind of just like, it uses action message format, or the beautiful, beautiful Adobe or Macromedia, whatever, who invented that, action message format for communications. Because the admin panel, again, it's in Flash. So why not? Another thing to note is that they used to have an OS X and Linux endpoint agent, but they became Windows only because, maintaining software is hard when a big company buys you and they lay off all your people. I don't know if they did that, but that's my theory. All right. Oh, okay. Also, the backend, this isn't so bad, but it's Apache, Jetty, and MySQL. MySQL did kind of seem like an odd choice for something that's supposed to be enterprisey software, but YOLO. Okay. These are not animating. Okay. Anyway, so Bravo DLP, the management console, is an MMC snap-in. It's Windows-based. The backend is MSSQL. The content monitoring server is also Windows-based, and it's separate from the management console. The endpoint agent, again, Windows, has a lot of drivers and hooks, as you might imagine. And the endpoint agent is similar to Windows, but it has less support for. So the OS X agent isn't as robust as the Windows one. They also use a lot of open source free libs. Hopefully they are using the proper licensing. I don't know, I'm not a lawyer. Such as Boost, FreeDSC, etc. Oh, now it animates, right when I'm about to, okay, whatever. Charlie DLP. Go. I'm just going to do all these because I don't know why it's not, all right. Are you going to do it? No? Well, fine. Okay. There we go. So virtual appliance, kind of the same theme, Linux. Endpoint agent, Windows, does file monitoring and scanning, monitors clipboards, monitors network traffic and URLs coming out of the operating system. The endpoint agent is Ubuntu and Debian. It has file monitoring and scanning. It has a little notification tray ring thing in the GNOME KDE that pops up and says mean things to you, I guess. The OS X endpoint agent, we really didn't look at that much, but it exists. All right, Dingus. It totally is not a real thing. We didn't change the name because these people were mean to us or anything. Oh, nope. Oh, shit. I'm not good at slides. I don't know how to computer. I just got this computer from my mom. She put some video games on it and stuff. There we go. I think that's it. Oh, nope, that's it. Okay, good. So, again, Linux management system, network appliance is Linux virtual. That can be used in a variety of ways. One, inline, you can do a tap or a span port. Basically, you can use it either to monitor traffic, proxy traffic to something else. The Windows endpoint agent monitors the clipboard. It can look at the file system, and again, it can act as sort of a network monitor. All right. So now we talk about how we did this, what our sort of methodology, our assessment criteria was. Again, this was less to figure out how effective these products were, although we did throw some stuff at it and make sure that it was alerting properly and working as intended. But mostly we were interested in the security of these products. Why should we spend money on these products, spend all of our time putting them into our infrastructure if they're going to be like a giant mess of security problems? Okay, so in terms of the network appliance, we're going to run the paces on the parsers, right? What happens if we throw invalid or mangled files at it? Maybe we can do some fuzzing, see if the parser throws up on stuff it didn't expect. In terms of the update deployment, okay, is it encrypted? Are the updates, properly signed, properly, encoded, or not encoded, encrypted or whatever? Are they using SSL? Or is the certificate good? Is there certificate pinning? That sort of thing. The operating system that they're using for their virtual appliances or whatnot. Are those operating systems hardened? Are they out of date? Are they using a really, really old version that if I update it, it's going to break everything? Is the operating system hardened, or is everything running as root? Are we, properly jailing things if we need to jail them? Are we basically running it as a less privileged user and then escalating privilege only when we need it, dropping it when we don't need it? For the endpoint agents, again, we're going to look at the parsers, throw weird stuff at it. Same thing with the updated deployment mechanism. Also look at the drivers and services that they do. Okay, the endpoint agent can be tying into a lot of things. It can be looking at the file system. It can be looking at your interaction with printers. It can be looking at your interaction with the network stack. So those are a lot of things that the endpoint agent can get its hooks into. We want to see if they are properly handling. What happens if I send a whole bunch of weird packets to this endpoint? Or what if I try to open up a really, really funky file or whatnot? What's going to happen? Maybe it's monitoring print jobs and I send a really, really weird print request with malformed data. Is it going to crash? Is it going to throw up? And then for the management server, most of these are web app interfaces, so our typical, OWASP top 10 type stuff comes in. The database that we use to store policies and other sorts of information, we're going to make sure that the data is stored in a good way, so anything sensitive should be encrypted. The configuration should not be no password or running as root. And same thing with the operating system. Make sure that we have the operating system is up to date, is hardened, and is not configured in a way that is not considered best practice. All right, 20 minutes to go, or less than that. Let's just go through all of the stuff we found. So before I go into specifics, we're going to go vendor by vendor. I just want to talk about general observations, just the trends that we saw overall in terms of things that it seems like everybody is kind of not getting right. So the Linux appliances, we did see a very big lack of hardening. There were some things that could have been locked down a lot more. We did see things running as root where they shouldn't have been. So that's maybe one of the things that they expect you to do yourself. But as somebody who's selling you a solution, we kind of expected that those were a little bit better than they were. So again, a lot of services run as root. They weren't using any sort of exploit mitigation, in terms of memory corruption or code execution preventions. The endpoint agent software, again, we talked about how this stuff has access to a lot of stuff. We want to lock it down. The endpoint agents, out of the box, usually ran as very, very high level of privilege, root, local system, administrator. And then just general absence of best practices. Like we really didn't expect it to be as easy to find problems as we did. Things where they didn't encrypt their communications, where they didn't, I don't know if the OS top 10 is pretty easy to find. I don't know, I don't know what's going on. We'll get into that. And then occasional bug inheritance. They're using libraries that have bugs that either haven't been patched or they're using an outdated version. We'll go into specifics when we get into the different targets. But we did see people using things like outdated JREs, free DCE, and whatnot. All right. So the part where people actually came to this talk for. All right. So again, I said, and again, this is going to come off as a rant, and maybe this whole talk really isn't a rant, but one of the things that I kind of always expect from a vendor, especially a vendor that, is asking you for a lot of money and is, basically making the bulk of their profit from selling people security solutions and whatnot, is that you should not have vulnerabilities that are so obvious that an intern can find them. And these are just different pages. Some of these are reflected, some of these are stored, but there was cross-site scripting all over TrendMicro, which was something that I didn't even find most of these myself. I was like, no, because I was running Burp Suite, and Burp was like, this might be I'm like, no, why? They patched this, I'm pretty sure they patched this. Another one, again, on. Cross-site request forgery. We learned this, what, like, okay, so what can we do? You know, you can make policies or whatnot, so why don't I see if I can trick an administrator into making a policy? Maybe I make a policy that allows me to do whatever I want. Maybe I make a policy that blocks people from doing stuff they have to do. Let's see if we can actually, what am I doing? Okay, this needs to go faster. But you guys all know what, and gals all know what cross-site request forgery is, so I'm just, what am I changing here? Oh, so I just changed the policy number. Was it the policy? Yeah, I just changed the policy number to ODE just as a regular proof of concept. So if we go in and then go back to the panel, we should, yeah, let's go look at what our keywords are. All right, now I have a keyword list called ODEs, and I could fill that with whatever I want. I could create a policy using that keyword list. Another one, again, Trend Micro hopefully has fixed most of this stuff. I'm pretty sure they have. We were kind of looking at some of, this is their remote crawler. So basically you say, hey, I want to, this is my agent on my Windows desktop. I want you to crawl this and see if there's anything weird going on. Like, does she have files on her system she shouldn't have? Does she have a list of everybody's salary or something in an Excel spreadsheet? And all that was in plain text. Which is, nobody, hopefully you just work at a company where nobody knows how to run a packet sniffer. So that was Trend Micro. Just really disappointing, especially for the first thing we looked at. Okay, so Sophos. Sophos was actually surprisingly not that bad. Most of the code was in .NET, and they were using the MS Core libraries, which modernly tend to be pretty good. Database best practices, so using stored procedures, parameterized queries. They were encoding their input and output pretty well, and they were using encryption libraries, which were not broken. So good job, Sophos. That was on the endpoint. Same thing came for the other manager. So they were che-rooted, they dropped privileges. We didn't see a lot of web vulnerabilities, just some low impact stuff like information leakage. The network and login access control restrictions were pretty locked down too. Okay, Opendlp, just a note on Opendlp, we just didn't find a lot just because there really isn't a lot of functionality. We did find cross-site request forgery, which, again, you can trick somebody into creating a profile that they didn't intend to create. Okay, so let's talk about WebSense for a little bit. As you would expect for most policies, they contain keywords, regular expressions, or whatnot. But the interesting thing about these specific policies for WebSense are they actually made them as Python pickled objects. So what happens is the management server, they take the policies, they bundle them, they encrypt them, and then they push them to the agents and appliances, saying, here's the new policy, go do policy stuff, use the policies. So if we are able to, let's say I'm a local admin and I really, really hate my job, or I really, really hate DLP, or maybe somebody slipped me some money to do this, if I replace the policy file, which is a .pic, or its pickled object, with my custom pickled objects, and you probably can't see that very well, but we're basically replacing a legitimate policy file with some bad stuff, and we were able to get a reverse shell from the protector after the policy update. And we're root. So that was not good. So yeah, if you want to pop a machine as like an admin on this, I mean, you shouldn't be able to do it anymore, but again, DLP is in a very advantageous position. Being able to do stuff like this is no bueno, it's not good, okay. So let's go into the smaller ones, and I'm kind of going fast just because there are a lot of them. But Alpha DLP got some things right, which is good. They didn't have any cross-site request forgery. They didn't have any. Remember, Alpha DLP is the one that uses Flash and a whole bunch of other stuff that we didn't like. We didn't see any cross-site slashing in the management application. Okay, great. They used Hibernate to talk to their databases, so we couldn't find any SQL injection, which is good, but they didn't put any authentication on the MySQL database. Womp womp. Also, we talked about reliability, and having something on your system, something that's sitting on a lot of machines, something that those machines have endpoints that need to talk to your management server, having something that crashes a lot is, basically not very good. It's just going to make everybody's lives miserable. People hate security people enough as it is. Forcing, subpar products on them is just going to make everyone hate us even more. This thing crashed harder than, I'm trying to think of who's a celebrity who's known for getting into a lot of car wrecks. I can't think of one that, Lindsay Lohan, I guess. It crashed a lot. I would say at least once an hour, and that's maybe being generous. This thing went down harder than, what's her name, that boxer that got punched in the face by Holly Holm. Yeah, it was really bad. It's not good. So that was just the server. For the admin, we saw a lot of marshalling between Java and Erlang, as you would have to do. We did see that maybe there would be some potential heap corruption there. We didn't really get enough time to investigate, but maybe something for future. But the bad thing, the thing that made me really, really upset, and I started crying, I didn't really start crying, they're using a really, really old JRE. And I know that it's perfectly fine to never update your Java. Nothing bad ever happens if you don't update your Java. But this is really old. And I tried to update it and it broke everything. So yeah, not good. There was also some path manipulation with the Erlang rules, so maybe you could get it to point somewhere it shouldn't be looking. And they also didn't sign on their, remember, it's Erlang, Java, and .NET. On the .NET assemblies, they didn't do any signing. So, if you're unfamiliar with assembly signing in .NET, basically you can put some protective, hashing or whatnot so that the runtime will verify the signature. If the signature doesn't match the assembly, then it says, this has been tampered with, I don't want to run it. They didn't put that on there, so I was able to do this. And I think it's a fast improvement. So instead of having our, whatever this, we have the threat butt, intelligent agents, global APT configurator. And this is what it looked like. I just took out the vendor stuff, and this is what I did to it. I basically just injected new, here I just modified strings and changed the binary for the logo, which is fine. But again, you could make this agent do bad things. You could basically rootkit it and hide inside that agent if you were savvy with .NET. Okay, okay. Bravo was probably one of the more complex ones. I'm just going to go through one that, this one real fast. It was really heavily reversed. We didn't really find anything, so we got really lazy. They used DCERP for agent server comms, maybe that's why. They did a lot of encryption, packet privacy, except for the OSH agent, which is all plain text communications. Oh, dude, again, this is, So pretty good, except, come on, encrypt stuff. Okay, sorry, it just keeps going. For Charlie DLP, no anti-CRS tokens. All operations are done RESTfully, so you can CSR, why is this not working? You can CSRF an admin and delete the policy. All right, these slides are fucking fucked up. I think maybe I clicked it too much and it's just going. All right, I'm just gonna stop it. The registration of endpoint agents is done by SOAP API that does not perform authentication, and you can also inject stuff into the admin console. These are super amazing JS alert skills. So basically, we gave it some C data in an XML file, and it was like, whoop, there you go. All right, let's look at Dingus. Again, Dingus may or may not exist. Dingus may be a figment of imagination or something that came to us in a fever dream. It's real, we just don't want to. So first thing, they have a support account that is totally not a backdoor. I mean, it reverse SSHs to an Eastern European proxy somewhere, but nah, that's no big deal. Nothing ever bad has happened if you find an Eastern European proxy. I mean, I love Eastern Europe. I just wouldn't ever want to find my machine proxying there. Okay, 5 minutes. Cool. Same non-password protected key on every appliance. Support can log in at root on every appliance, like that. And the support account is invoked for the web UI, so you basically have a reverse tunnel everywhere if you combine it with cross-site request forgery. You can also use the cross-site request forgery to do command injection. So what we did was, if you want to change the time zone, you just pass it the string of the time zone. Okay, well, why don't I just do touch TLP lol injection, and then we get a file on the system. And it's as Apache, so whatever you're uploading there will run as Apache, so maybe some sort of script, that would be nice. Okay, let's just skip lots of sudoers that are Apache. One of them is RPM. Okay, let's install stuff. Central console is unauthenticated DB, okay. The synchronization channel is just plain text Postgres. And, okay, so, all right, real fast. What about bypasses? Well, again, if you're dealing with somebody who really, really wants to get around it, it's very likely that they're going to be able to, or that they're going to get somebody hired into your company who is able to do it. Okay, so what can we do? We can use obscure file formats, obscure protocols, do weird things on the network, side channels. Any of you who are working at finance who use Bloomberg Terminal, they have their own chat and their own email client. Are you monitoring that? Hopefully, okay? Using obfuscated encrypted files, maybe doing some steganography within those files. And then again, who do you trust? How many of your users have elevated privileges? How many of them can just go around disabling agents, okay? Just as a final note, because I know that there are probably, we always get people in the audience, they're like, oh man, so DLP just sucks and I can't use it, and this sucks, and like, what am I gonna do? So it still has value. Oh, why didn't it? Oh, it's all one slide, great. It still has value. Just make sure that what you're getting, kick the tires in terms of security before you actually give them all your money. But it still has value, like in defense in depth, right? You should have your firewalls blocking stuff you don't need. You should have IDS monitoring for stuff that is not supposed to be happening, such as really, really large or atypical file transfers. You want to monitor your side channels. Again, the example of Bloomberg Terminal, other communication systems that may be available to your employees. And then really, at the end of the day, you need to basically talk to the person who is going to use the, oh, I didn't know I couldn't do that excuse. Educate people, educate them frequently. When you catch them doing something wrong, which is where DLP should come in, come to them, be nice to them, just say, I saw you were doing this, here's a way you can do it, or here's something you can do instead that isn't going to violate policy, get us all in trouble. And again, know who your people are, take away access when they don't need it, they leave, terminate their account. I know a lot of people who forget to do that. And again, audit your stuff regularly. Do these people still need these permissions? So on and so forth. And just a fast thing for takeaway, again, everything you buy, everything you put in your network can and will add additional attack surface. So you buy something or you're looking at buying something, if you can't do it yourself, see what security they've had done. Have they had their code scanned? Have they had a code audit? Have they had any sort of penetration tests done by anyone? Ask to see those reports. Ask them if you can hire somebody to actually do some security analysis on them. If they say no, then maybe try to scratch your head and figure out what. I don't like the excuse, what do you have to hide? But if I'm going to give somebody money, then they better freaking, show me the stuff, the goods. Okay. And just at the end of the day, and this is, this is the rant that I come on. You're selling me something. You're a security company. You are a security company, right? Why are they not finding these things? A scanner can find it. An intern can find it. My mother doesn't know how to turn on a computer, but once I turn it on for her, I could probably teach her how to find some of these, okay? And again, when you're considering a solution like this, you have to know who you're defending against. If you're really worried about a Bradley Manning or somebody who's already trusted, who's inside your organization, you're going to have a really different method of trying to catch those people than just, the administrator who copies everyone's salaries out of a spreadsheet and accidentally emails them to everyone in the company, right? And again, at the end of the day, everyone has a cell phone. You might want to worry about that too. So we only have 2 minutes, but I could probably take 1 or 2 questions if there are any. That's me. The dog. Also, that's my email address, GeorgeSims@DrupMicronics, and I'm also Aloria on Twitter, if anyone wants to harass me. I apologize for going over.
So my question is, are the agents smart enough, or have you seen instances where the files are being transferred to the management server for analysis?
So you're asking if the agent is smart enough to see if it's transferring what to the management server?
The file has been spec'd, or the data, or...
I mean, so they do, they generally do what they're supposed to do. Like, if you're trying to email something or copy something you're not supposed to, as long as you're not being like super sneaky about it, it will usually catch it, right? It's good for what it's supposed to do. But if you have somebody who's maybe going to, sometimes, it also depends on your policy. If somebody is going to encrypt a file and email it somewhere, you got to configure it to say, no, you're not allowed to send that, right? So it also comes down to people may be able to trick the scanner or the endpoint agent because you haven't properly told it, all of the different loopholes that people might try to jump through.
Would you see DRM solutions as a replacement or as an addition to DLP?
Yeah, so DRM, like if you are looking to, if you are thinking about DLP just to kind of keep people from stealing intellectual data or whatever, I think it's, I'm not really a lawyer or anything, and the argument against DRM is, it is something that's being able to bypass, but again, depending on who you're defending against, it can be an additional layer of protection, with respect to, we put this DRM on there, you took it off, you've clearly produced evidence, or you basically, like changed yourself. Like you're basically like, by breaking the DRM, you've basically proven that you had bad intent or whatever. Like you did something that we explicitly told you not to do. So again, like DLP can catch people trying to do that. DRM, I guess, is just a different method of trying to, keep people from, keeping honest people honest, rather. Oh, this one right there. And is the score still 0-0?
Did you find anything related to these scanners, how fast do they give up? Like, let's say I encrypt a file with some weird hashing algorithm I maybe invented myself. Are there any scanners that say, fuck it, just let it go through, or, yeah?
So usually what would happen, it wouldn't be more of the scanner being like, I didn't do this, or like, this is taking too long, send it through. It was more like the scanner was like, I don't know what this is. I don't have a rule saying what to do with this. All right, whatever, bye. There have been instances where we did send like really, really funky stuff to it and it thought it could scan it, but it didn't fail open. It basically, usually they just throw up and crash. So that's, unfortunately, I mean, yeah. There's one person here, right in front of you.
So what has been the vendor response, and have they patched all the vulnerabilities you have reported?
So there were some of them that we didn't get the updated version, but so that's actually a funny story, is that we, when we found these, we're like, we're going to report them. Why? We're nice people. We don't need to have a bunch of ODA rolling around. It was actually kind of difficult for some of the vendors. Like they didn't have, none of them had bug bounties. A lot of them didn't have easy ways to contact people. And in some instances, we actually had to go through support and say, I'm not somebody who is I'm not like an enterprise client of yours, but we found something. Can you like give us an email address? So just reporting them was difficult in a lot of ways because a lot of these bigger companies aren't really set up for that sort of thing, which is kind of weird. Yeah, once they found out, they did actually fix the stuff. The ones that we could verify, at least, they did fix it. So hopefully the other ones were, but yeah, we did tell everybody that we found bad stuff. So we're trying to be good citizens, despite mocking them on a public stage in front of all you people. All right. Cool. All right, thank you very much. Sorry for the going a little fast at the end, but hope you enjoyed it, and have a great rest of your conference.